Hello and welcome back to Zig's Math Lessons. This video focuses on solving a couple of problems involving derivatives. Problem 1. Find the equation of the tangent to the function y equals square root x plus 1 that is parallel to a line, some other line, x minus 6y plus 4 equals 0. Solution. The plan is to set the derivative of the function equal to the slope of the line, because the derivative is the slope of the tangent, and when two lines have got the same slope, they're parallel. Now, finding the derivative of the function. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h, which I've shown here, and rationalizing and multiplying it out to a difference of squares, canceling what cancels, and taking the limit all in one step, we have the derivative of the function. Pause the video and observe the details if you need to. Now that we have the derivative of the function, we can turn our attention to the line. There's the derivative of the function. Now the line can be rearranged to y equals mx plus b form, and we can see that the slope of the line is 1/6. So we'll set 1/6 equal to the derivative, cross multiply, solve it, square both sides, solve it. Now we know that x equals 8, and y will be the result of subbing 8 into the function, and that will be the number 3. So our point of tangency is 8, 3, and the slope we know to be 1/6, and so we can easily find the equation of the tangent that's parallel to the line by using y equals mx plus b. Those details I will leave to you as an exercise to confirm that this is the equation of the tangent to the curve y equals root x plus 1 that is parallel to the line x minus 6y plus 4 equals 0. A second problem. Find the equation, possibly plural, of the tangent from the point 1 minus 3 to the function y equals x squared, our familiar parabola. Solution. One must notice that the point is not on the function. We seek the equations of the tangent lines shown in this rough diagram. Here's this point 1 minus 3 external to this parabola y equals x squared. And from this point we can draw tangent lines, one that goes here and one that comes over here. And we want these equations. This is a point of tangency, which we could label a sub 1, whereas this one would be a sub 2. And of course, the coordinates would have to be a and a squared. Our plan would be to express the slope of this tangent line in two different ways. One using the derivative of this curve, and one using, the other way would be using the slope of a line from grade 9 math. So let's first express the slope of this tangent line using the derivative of this curve by finding the derivative. First we find the derivative. Well, the derivative is the limit as h approaches 0 of f of x plus h minus f of x over h, which is as shown. Multiply it out, offset what offsets, common factor out the h, cancel and take the limit. We have the derivative of the curve is 2x. And so, because the derivative of that curve is 2x, the slope of this tangent must be 2a, because it goes through a point where the x-coordinate is a. So the slope here must be 2a. But the slope is also y minus y over x minus x, using the grade 9 formula, as well as being 2a. We can equate the slope to the slope using y2 minus y1 over x2 minus x1 and solve for a. So this will be y2 minus y1 over x2 minus x1 and equate that to 2a. We need to solve this equation for a, and we've got our point of tangency. It looks like this when you multiply both sides by a minus 1, equating to 0. It looks like that, factoring, and we have a equals 3 or a equals negative 1. Taking them separately, if a equals negative 1, then we know it's on the curve, so y must be x squared because y equals x squared, so the y value must be negative 1 squared. Meanwhile, if a is 3, then the y value that goes with the 3 must be 9 because y equals x squared. And there we have our points of tangency. We have our points of tangency. We have our slopes. M1 is when a equals negative 1, and we know that the slope is always 2a, so it's 2 times negative 1, or 2 times 3, 6. So we have our slopes, we have our points, and we now have our equations using y equals mx plus b. And I'll leave the finding of the equations given this information to you as an exercise. I hope this illustrated some of the ways we use calculus to solve problems. If you like the content, please subscribe and tell your friends and help me grow my channel.